Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Chemistry Online with Mr. Ahmed Sulaiman. Today we are going to study acids and bases according to the third theory, which is Lewis theory. We studied before Arrhenius theory and the Bronsted theory. Today we are going to study Lewis. Lewis, acid and bases. How did Lewis define an acid and base? Let's recall what we studied before about acid and base according to Arrhenius and Bronsted and Lorry. In the case of acid, for Arrhenius, the acid is the substance, molecule, or ion that release or produce hydrogen ion, positive, or proton. So, acid is a hydrogen ion producer. The base of by Arrhenius theory is the molecule or compound that produce OH negative or hydroxide. It means it is a compound that hydroxide producer. This is Arrhenius. Bronsted-Lorey theory said something else, because they found some compounds don't have OH, but they are bases, or they behave as bases, like NH3, if you remember, and sodium carbonate, Na2CO3. So the base, according to Bronsted-Lorey theory, is the substance that accepts hydrogen, or we can say hydrogen ion acceptor. But the acid is the substance that produce, or we can say donate hydrogen ion. Almost the same meaning for Arrhenius here, but the difference between the two theories in the meaning of the bases compound. Remember that now we have Lewis acids and bases. You remember why Bronsted-Lorey built their theory? Because they found some compounds, as I said, don't have OH. So how can they produce OH negative although they behave as base? This is a problem. It happens again with some compounds. Some compounds don't have H's at all, or even OH's, and they behave as acid or as base. Like acid and base, according to the electrons. According to Lewis, an acid is the substance that accepts pair of electrons. Accepts electrons, okay, but must be pair. Pair means double. Pair of electrons. The base is the opposite. It is a substance that donates a pair of electrons. Remember, the acid in the Bronsted-Lorey produce or donate hydrogen, but now by Lewis it accepts pair of electrons. The base of Bronsted-Lorey, it was accept hydrogen ion, or acceptor, as I said before, hydrogen, But now the base by Lewis donates pair of electron. Don't confuse, please. Now we need definition for this theory, acid-base meaning. Lewis acid is a substance that can accept pair of electrons, as I said, to form covalent bond. Lewis is the opposite substance that can donate pair of electrons to form covalent bond. Now we have a new meaning for acid and base according to the electrons, and it's more clear than Bronsted-Lowry and Arrhenius. Consider we have hydrogen reacts with hydroxide. They are ions. It means it's a compound like HCl, for example, or H2SO4 or whatever, or HNO3. But we do it like H positive. But H positive doesn't react alone. Yeah. Okay, if you have H positive like this, reacts with compound like NaOH, like KOH, like this, reacts with hydrogen reacts with OH negative in a compound. Which of them is an acid? Which of them is a base? According to what we studied in Lewis, we said that the acid is the substance that can accept pair of electrons. So hydrogen is the acid. Why? Look, hydrogen is a positive ion, but OH has 3 lone pairs, or we can say unshared pairs of electrons. 3, not only 1. And we need only 1 to make this. It has 1 unshared pair. It can give them to hydrogen here, or we can say coordinate. Remember the coordinate bond. It coordinates with hydrogen, and hydrogen now accepts a pair of electron. So it's an acid. Remember again, the substance that accepts a pair of electron, it means it's an acid. Now hydrogen accepts a pair of electron, so it's an acid. The opposite for OH. OH has an unshared pair here, and it gives this unshared pair to hydrogen. It means donates. So the substance, as we said before, that donate a pair of electron means it's a base. It means OH is a base at this case to form water molecule. This is an example to understand the acid-base meaning related to Lewis theory. Is it clear? So OH is Lewis base, but H is because it accepts a pair of electrons, so it's an acid. Now, to avoid confusion, remember again, Arrhenius defined the acid as hydrogen producer, but base is hydroxide producer. Bronsted-Lowry theory said that the acid is hydrogen donor, but base is hydrogen acceptor. Lewis said something else. He said electron pair acceptor is an acid, but if it donates electron pair, it means it's a base. I think it's clear now. You know, Lewis here more clear than the others. Why? It's related to the electrons. And all substances contain atoms. And all atoms or even ions have electrons. So you will not find a substance, you cannot explain which compound is it, acid or base, because it has electrons. So you can identify if it accepts or donates electron, and you can identify it's an acid or base. But in this case and this case, some compounds maybe don't produce OH because it doesn't have OH, so we can't apply Arrhenius for all compounds. And also some compounds don't have H's to explain it donates hydrogen or it accepts hydrogen. So we have a problem with them. They are not wrong, but we have problem with them because of this meaning in some compounds. But Lewis explains the meaning. Let's do another example here for ammonia and boron trifluoride. Recall what we said before about NH3. According to Bronsted-Lowry theory, we said that before, and nitrogen in ammonia has a lone pair of electrons. If it reacts with water, for example, H2O, what happens here? It gains or accepts hydrogen and becomes NH4 positive. It means it accepts hydrogen. Because of that, it's a base. Because base accepts hydrogen, as I said before. And water donates hydrogen, so it's an acid. You remember that? So NH3, according to Bronsted-Lowry theory, it's a base. The same now for Lewis. No change here, because we have NH3. It's a base as well, but not because it accepts hydrogen. No, but because the meaning of Lewis, ammonia, as I said, has lone pair of electrons like this. And the base is a substance that donates a pair of electrons. It happens for this example. It will give this unshared pair of electrons to the boron in boron trifluoride. And they will form a bond between them, and there will be NH3BF3 compound. At this moment, because ammonia donates a lone pair or unshared pair of electron, or pair of electron, it's a base by Lewis meaning, but boron here in boron trifluoride accepts a lone pair or unshared pair of electron, so it's an acid according to Lewis theory, and it's clear to see this now. Look, that's what happened. The lone pair boron, and they make a bond between them. The bond is formed here and becomes a compound like this. This is the meaning of acid and base. And now we can identify, like this example, Lewis base donates pair of electron, so ammonia in this case is a base. Lewis acids accept a pair of electrons, so boron trifluoride is an acid. And this is the meaning, and this is the end of our list today. Thank you يا شباب.